Now friends, in this lecture we are going to solve some previous year questions based upon the formula which has already been derived in my previous lecture. First take this question that has been asked in GATE 2008. If the length of wire of resistance R is uniformly stretched to n times its original length, its new resistance is, we know that R is directly proportional to L square. So simply new resistance will be equals to n square R. Okay, where R is the initial resistance, and why it is so? Because new length is become n times, it means NL. That's why R new is equals to n square R. Now see this question. A wire is drawn of resistance 5 ohm is further drawn so that its dia becomes 1/5 of original. Okay, 1/5 of original. Now what is the resistance if volume is constant? So new resistance will be equals to, we know that resistance is inversely proportional to the fourth power of dia. So we can write this is initial value of R 1 by 5 d to the power 4, 1 by 5 to the power 4, so we get R 5 to the power 4. Okay, so it is very simple, we get 625 R, and initial value of resistance was 5 ohm. Okay, so we put 625 into 5, that is equals to 3125 ohm. Now see this question. A copper has resistivity of 17 into 10 to the power, this is minus 9. Okay, minus 9, and length 2 centimeter and cross section 5 into 1 mm square. Here we have to find the value of resistance R. See, here resistivity is given 17 into 10 to the power minus 9 ohm meter. Okay, and length is 2 centimeter. It means length is equals to 0.02 meter. Okay, and area of cross section is 5 into 1 mm square. It means area A is equals to, in meter square, is equals to 5 into 10 to the power minus 6 meter square. If you put all these things in, R is equals to rho L by A, where rho is given 17 into 10 to the power minus 9, L is given 0.02 meter, and area is given 5 into 10 to the power minus 6, then you can easily get the answer. Okay, so you solve this question on your own because it is very simple calculation. Now see what happens to the resistance if length is increased 3 times and dia is halved. Okay, so in this case we can write it as R new, suppose, is equals to rho L by A. Okay, and we know that area is equals to pi d square by 4. Okay, so question says that if its length is increased 2 times and dia is halved, it means we can put length is increased 3 times. Okay, now we are finding new resistance. So length is increased 3 times and dia is halved. Dia is halved means d by 2 dia becomes d by 2. So on solving this we will get 12 rho L by pi by 4 d. Okay, and rho L by pi by 4 d is equals to R, so we can write 12R. So new resistance has become 12 times of original resistance. So this is also very simple. Now next question has been asked in ES 2000. Okay, so it says that hot resistance of bulb filament is higher than the cold resistance. Why it is so? We know that conductors have positive temperature coefficient of resistance. Positive temperature coefficient means the resistance increases as temperature increases. So that's why hot resistance of bulb filament is higher than its cold resistance. So these are few basic questions that are based on the theory that has already been told to you in my previous lecture. So you can easily solve all these questions. Now see this question. Here in this question, energy required to move 130 coulomb charge through 3 volt is. This is questions on the basis of very basic concept. We know that energy is equals to work done and work is equals to Q into V, where Q is given, that is 130 coulomb, and V is given as 3 volt. So energy required is equals to 390 joules. So this is the answer of this question. Now see this question. Here in this question, this graph is given and we have to find the charge transported from 0 to 6 seconds. So this is very easy question. We know that charge Q is equals to integration I t dot dt. Okay, but this integration is simply equals to area under IT curve. Okay, so if we find this area under IT curve, then this area will give the charge transported. So what is this area? First take this area. Okay, so Q is equals to, suppose this area is A1, and what is A1? That is equals to, this is a triangle, that is half base into altitude. What is base? That is 0 to 3. This is time axis and time is in second. So 0 to 3, that is equals to 3. And what is altitude? That is equals to this 5 ampere. So A1 is equals to A1. What is A1? A1 is equals to 7.5. Okay, now see, this area is negative and this area is positive. So we have to subtract this negative area from positive area. If we subtract negative area from positive area, then we will get the net charge transported. Okay, so what is this negative area? See, this negative area is made up of these two triangles and this rectangle. So this area is equals to, what is area of this triangle? So area of this triangle is equals to half base into altitude, and this is, sorry, this is -1. Okay, so what is this area? That is half, what is base? Base is equals to 1 and altitude is also equals to 1 plus, now this is a rectangle. Okay, this is a square. Here this width is 1 second and this is 1 ampere. So 1 into 1 plus, now take area of this triangle. So that is equals to half base into altitude. Half, what is base? That is equals to 1, and what is altitude? That is also equals to 1. So finally we get A2 is equals to, and we have to take negative sign because this is negative area. A2 is equals to minus 0.5 plus 1 plus 0.5, that is equals to 2. So that is equals to -2. So this is area A2. Now what is net area? Or net area is equals to total charge transported. Net area is equals to 7.5 plus -2. So finally we get 5.5 coulomb. So this is the net charge transported, and charge is equals to area under IT curve. So this is the solution of this question.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.